Sometimes when we take the limit of a function, it's not going to be infinity over infinity or 0 over 0 to able to use the L'Hopital rule. However, in some cases, we can rewrite the given function so that we can use the L'Hopital rule. Here we have three cases. The first case, if the limit is infinity multiplied by 0, here we can rewrite the given function in terms of fraction. That fraction gonna give us infinity over infinity to able to use the L'Hopital rule. The second case, if the limit is infinity to the power of 0, here we can take the natural log of the given function, since the natural log of x at the n is equal to n multiplied by natural log of x, and then maybe we can use the L'Hopital rule. The third case, when the limit is infinity minus infinity. Here, this is most of the time gonna be two fractions. So by adding or subtracting this fraction, we will get one fraction, and maybe we can use the L'Hopital rule. This L'Hopital rule apply, and we are giving the limit as x goes to 0, e to the 4x minus 1 cosine of x. First step gonna take the limit, so here I'm gonna substitute x equal to 0, and going to be e to the 0 minus 1 over cosine of 0 is just 1, so 1 over minus 1 over 1, and that gonna be 0 over 1, so that result in 0. Therefore, we didn't have to use the L'Hopital rule in here. Therefore, it does not apply. Here, limit x to 0 sine of x over e to the x. Again, the first step is to take the limit. Here, x equal to 0. So we're gonna have sine of 0 over e to the 0. Sine of 0 is 0, and e to the 0 is 1. Here, 0 to 1 is 0. Therefore, we did not have to use the L'Hopital rule. Therefore, L'Hopital rule does not apply in here. Here, limit x to the 1, x over x minus 1. Again, the first step is always to take the limit. So here, I'm gonna substitute x by 1, and it's going to be 1 over 0, which equal to infinity. So therefore, we don't have the condition to apply the L'Hopital rule in here. Here, limit x to infinity, x e to the minus x. So let's take the limit in here. I'm gonna substitute x by infinity. And then I'm gonna write the second term as e 1 over e to the infinity. This term, the second term, gonna be 0. And then we will have infinity multiplied by 0. Now, notice this is the first case. So what I'm gonna do now, I'm gonna try to rewrite the function so that I can use the L'Hopital rule in here. So I'm gonna write this. I want to make it in terms of a fraction that gonna result when I take limit infinity over infinity. Notice here, I just move e to minus x to the bottom, and now I want to take the limit. Now I'm gonna substitute x equal to infinity and result in infinity over infinity. Now I can apply the L'Hopital rule. Limit x goes to infinity of x to 1 over x. Here, first step again is to take the limit. So I'm gonna substitute x equal to infinity. It's going to be infinity over 1 over infinity. Notice 1 over infinity will go to 0. So we'll have infinity to the power of 0. Notice this is the second case. Therefore, let's try to write x1 over x so that we can use the L'Hopital rule. So I'm going to do here, I'm going to take the natural log of this term. So I'm gonna take natural log of x the power 1 over x. Now using the properties of natural log, it's gonna be 1 over x multiplied by natural log of x. Now I want to take the limit of this function. Now I'm gonna take x, it goes to the infinity, then it's gonna be infinity over infinity. Now we can use the L'Hopital rule. Here, limit x goes to infinity of 1 plus x to the 1 over x. So again, first step is to take the limit. So here, x goes to infinity. It's gonna be 1 plus infinity, then 1 over infinity. 1 over infinity is just 0, and then 1 plus infinity is the same as infinity. So we have infinity to 0. This is the same as in the previous problem. So here what I'm gonna do, I'm gonna try to rewrite the given function. I'm gonna use the natural log. So I'm gonna take the natural log of the given function. It's gonna be natural log of 1 plus x and all to the power of 1 over x. Now using the properties of natural log, you will have 1 over x and the natural log of 1 plus x. Now what I'm gonna do, I'm gonna take this function that we just rewrite and take the limit of it. Now I want to take the limit, so that's gonna be natural log of infinity over infinity, which is the same as saying infinity over infinity. Here we can use the L'Hopital rule after rewriting. Limit as x goes to 0 of 1 over x minus 1 over sine of x. First step again is to take the limit. So here I'm gonna substitute x equal to 0, and that will result to 1 over 0 minus 1 over 1. Sine of 0 is 0, so that gonna result in infinity minus infinity. Notice this is the third case. So here what I'm gonna do, I'm gonna try to rewrite this fraction. How? I'm gonna make these two fractions into one, so I'm gonna add them. So this is our two fractions. I'm gonna multiply the first fraction by sine of x, top and bottom, and the second one I'm gonna multiply it by x, top and bottom. Now we have the same denominator. We can subtract these. Now I can take the limit of this function. So again, the limit of x goes to 0 of the given 1 over x minus 1 over sine of x gonna equal to the limit as x goes to 0 of sine x minus x over x sine of x. Now I'm gonna substitute x equal to 0. That's gonna be sine of 0 minus 0, and then gonna be 0 multiplied by sine of 0. This is gonna be 0 over 0, which make us to use the L'Hopital rule. So L'Hopital rule applies in here. Notice this problem is similar to the one. Here we have limit as x approaches 0 from the right, 1 over t minus 1 over e to t minus 1. Here the limit is not x but t. This is a mistake. So I'm gonna take the limit, so that will result in 1 over 0 minus 1 over 0. So that's gonna result in infinity minus infinity. This is similar in number 7, the previous problem. So here what I'm gonna do, I'm gonna rewrite these two fractions into one. So I'm gonna subtract them. I'm just finding here the common denominator so I can subtract them. Now since we have the common denominator, we can subtract these. So it's going to be, the bottom gonna be t multiplied by e to the t minus 1, and the top gonna be e t minus 1 minus t. So now we can write the given limit, the given function, and then what we rewrite it. So it's gonna be limit as x or t here versus 0 from the right as e to the t minus 1 minus t, then over t multiplied by e to the t minus 1. Here I'm gonna substitute t to be 0. So it's going to be e to the t minus 1 minus 0, and then 0, e to the 0 minus 1. So in the top we have 1 minus 1, and the bottom is 0. Here we'll have 0 over 0. Therefore, L'Hopital rule applies in here.